This video is on combinations of sequences. So the first line here is just a simple, straightforward thing. We've seen this a few times before. This is just going to be adding 2 every time. So this is just going to be 2n. We go backwards, taking away 2 from the 6 to get v4. Easy first part. Now the next part is again quite straightforward. We may notice here that we times by 3 every time. So then we know that it's going to be an exponential sequence, and it's going to be just 3 to the n, because 3 to the 1 was this, 3 to the 2, 3 to the 3, and so on. So that was another easy one to do. And at this point we might be just considering where this is going. You know, we've had a linear part, we've had an exponential part. I wonder what this is going to be. So this is another exponential actually. This is timesing by 2 every time. So it would be 2 to the n. But notice if you just did 2 to the n, the first term would be 2, not 1. So then to get the first term to be 1, that has to have the power of 0. So we have to take away 1 from this. So it's actually going to be 2 to the power of n minus 1. Still seems a little straightforward. I wonder then where it's going for part 4. Well, here, to go from here to here, it's times a quarter, or it could be subtracting 3. I'm not sure exactly, but here it doesn't seem to be following the same dividing by 4 thing, and it doesn't seem to be following the same subtraction. I mean, it could be a quadratic or a cubic or something, but because it's a part 4, this is exam technique. You have to really consider why you've had to do part 1. That was easy, that was easy, that was easy. This just is a mystery, right? So if we've had 3 easy parts and a mystery, you have to look at the first 3 parts and try to work out how you get it. So in this case, I think it's best, or easiest at least, to work out using the last number, because it's the largest number. So how do you get 681 using the last numbers from each sequence? Well, you probably start with this thing, and maybe you subtract these 2. So we could just try it. So 729 minus 16 minus 32. If you just wrap that into a calculator, see what you get. So 729 minus 16 minus 32 is 681. So it looks as though it's going to be all of the part 4 terms are the part 2 terms minus the part 1 terms, and then minus the part 3 terms. And as a sequence then, un would equal part 2, which is 3 to the n, minus part 1, which is minus 2n minus 4, because we're subtracting both parts, and then subtracting part 3, which is 2 to the power of n minus 1. And this is a combination of sequences. So this is really something to watch out for. You'd have never have got this just by finding differences. This is only found by inspecting the previous 3 sequences.